Hello everyone, welcome to Engineering Explained channel. In this session, I'm going to take limitations of first law of thermodynamics in the module 3 of lecture 1. In the module 2, we have taken the first law of thermodynamics. The first law of thermodynamics applied to a closed system undergoing a cyclic process, and also we have taken the first law of thermodynamics applied to closed system undergoing a change of state. That statement we have taken, which gives the conservation of the energy. And here, what are the limitations of that first law of thermodynamics so that it will lead to state the second law of thermodynamics? Limitations, if you know that, so that then the next statements of the second law of thermodynamics, which will be overcoming the limitations of the first law of thermodynamics, will come to know. In that first is that limitation direction of energy transfer, that the consent to the direction of the energy transfer, that is the limitation. The first law doesn't explain the natural direction of process or heat flow, as we know that heat is flowing from the higher temperature to the lower temperature. Okay, later by the second law we will come to know that one. But in this statement, it will not specify the direction of heat flow. The heat is flowing from the higher temperature to the lower temperature or from the lower temperature to the higher temperature. It is not mentioned in the law. For example, it doesn't explain why heat flows from the hot object to the cold object, but not other way around. Okay, why the heat is flowing from the higher temperature object to the lower temperature object. Other way, why it is not possible, it is not explained in the first law of the thermodynamics. The second limitation is that spontaneity of processes. It provides no information on whether a given thermodynamic process is possible or feasible to occur spontaneously. This heat transfer, what it is there, okay, the conversion of heat into work or a heat transfer from one system to the another system, is it occurring spontaneously or any external energy is required for to occur that one? That thing is not mentioned. That is the spontaneity of the process. It is not explained in the first law statement. A process can conserve energy according to first law, but still may not happen on its own in the real world. In the real world, the driving force is required. The higher temperature to the lower temperature, the temperature difference is the driving force or a force for the transfer of the heat. Okay, that is a potential force for the transfer of the heat. In the real world, that is not mentioned in the first law of the thermodynamics. Next is the completeness of conversion. The law does not specify the conditions under which heat energy can completely converted into work or vice versa. Here the heat energy completely converted into work or work is completely converted into heat, it is not mentioned in the statement. While mechanical work can be completely fully converted into heat, the reverse is not true. And the first law doesn't explain this limitation on energy transformation efficiency. Here, work is a high grade energy that can be completely converted into heat, that is a low grade energy. But heat we cannot convert into work completely. Okay, the mechanical work completely, and that limitation is not mentioned in the first law of thermodynamics. Then feasibility of a process. The first law is insufficient to determine if a particular reaction or process will actually occur to certain extent. Here, whether the particular process or a reaction is feasible or not, that is not clearly mentioned in the first law of thermodynamics. It is insufficient to explain. These are the limitations. Why the energy transfer is taking place, what is the direction, okay, whether it is complete conversion is taking place, whether it is feasible or not. These four limitations are there for the first law of thermodynamics, which leads to the second law of thermodynamics I am going to take in the further session. Thanks for watching. If you like, share, subscribe, and comment.